Welcome, I'm Bill Wake. We're here working on a Kaleidoscope program. We've done most of the work, but we never did get SwiftLint installed. So we installed that at the end of the day yesterday, and we're going to try and clean up the errors from that. And once we do that, I'm going to, I want to explore a little bit different way of finding the pattern in something and possibly do something that looks more like a real kaleidoscope where the pattern repeats multiple times coming at you. So we'll see how far we get. All right, let's save this. Okay, so what we did yesterday, we got the SwiftLint running, but there's a number of errors. Accessibility labels, okay, I can kind of buy that. This one, I don't think we need Geometry Reader anymore. So let's take that out here. I think we needed it, like Capturing View may have needed it, or one of the others like that. But it seems like it's not really. We've moved that functionality out. Camera Model, maybe Camera Model owns it too. Well, no, it would have to be on the Capturing View, I guess. All right, so we show the error, we show the text, we have the number of mirrors. That could be more of a parameter across things. But we'll see. I'm not quite sure how I want to do things yet. All right, good. I'm going to leave the other errors for later. The accessibility stuff, we'll come back and do that after we get these. Implicit return, oh yeah. Multi-line arguments with animation. Well, I think that is that's sort of a known error in SwiftLint, or restriction on it. It when it has multiple closures as arguments, it's perfectly legal syntax, but it gets confused and thinks we're doing something a little weird. I may take that warning out. I don't know. I make that mistake sometimes, though. Well, now am I correct on this first? Capture. That's that. Okay, then with animation has this call. Yeah, I think this is that SwiftLint problem. We'll come back to that. Shorthand binding syntax for optional. I don't know what that means. Attributes should be on their own lines, but on the same lines as... Okay, sure. My editor's still not spacing correctly. All right, now this one, shorthand syntax for optional binding. Whoops. Oh, if let, I gotta get with the program. If let foo, okay, good. I should get used to that one. All right. Accessibility, redundant type, yeah, that's true. Okay, let's run this. I lost track of where the running one went. Okay. Which I guess this one's actually running. We'll put it on Xcode. Okay. Good. All right. Well, let's commit. Oops, commit. Oh, what's the matter here? Oh, back to this. Clear all issues. Clean tests. Clean build. And let's run. Okay. Let's see what we have left. Are these... Oh, vertical white space. Accessibility, multi-line argument. I gotta figure out how to turn those off. Accessibility, accessibility. Yeah. I feel like, oh my gosh. I guess you would call this decorative. I don't know. It's like you can't say anything about it. All right. So accessibility label for image. And I know I need to up my game on accessibility. I'm not so good on it. It's accessibility label with nothing instead. For a view that doesn't display text. Let's put the accessibility label for image. Okay, this is probably more. Right, after the image, say accessibility label. I guess we could label this with Kaleidoscope image. I mean, I don't think... Yeah, I can't really imagine a blind person wanting to use this per se. So, I mean, I guess I'll take it as practice, if nothing else. So this is the Kaleidoscope view. Kaleidoscope. Okay. He doesn't like being after it. Okay. That's camera kaleidoscope. Capturing view. Well, take a label parameter. Okay, so we're just doing image string. I guess we could nil out the bundle. Those are the direct string ones. Okay. I don't know if... I guess I would call it decorative. Okay. Decorative. Let's see what else decorative does. No label. Yeah, I think that's fair. Now, is reader being used here? It must be somewhere. Yeah. Okay. This is capturing view. All buttons with tap gestures should include the is button accessibility trait. What do we do here? This one's really odd because there's no, it's not really directly displayed. Well, that's not really, whoops, here's ignore. I may have to live with this one. Oh, it is the sliding image, yeah. So maybe that's the wrong place to get the label. I mean, captured is displayed. Let's put the label in there. This is Now, I don't know if I can say. Yeah, maybe he's decorative too. It's a little weird, but. Okay. I don't know if I can say anything here. Yeah, we're doing things a little weird in the sense that this is not it's not part of the UI code like this is. It's a returned value that will get displayed somewhere at some point. But the place where it's displayed is the one that's really doing anything with it. All right. Well, let's run that again. There's that again. What is your problem? Did it run? Tukes96, welcome. We're doing some cleanup. So we've got this Kaleidoscope program, and I just installed SwiftLint, and I'm just going to kind of to the point of living with some of these things. We did add the camera thing so you can capture a photo of your Kaleidoscope image if you like, and we've captured a bunch. I guess that's another thing for my to-do is we talked Muchark 666 raised the idea of putting the images in a separate folder, their own folder's not the right word. Forget what they call those. But yeah, because you potentially could capture a bunch of these like I have here, and they're all just Kaleidoscope images. It'd be nice to have them. Was it notebook? Whatever that term is, but it would be nice to have them all under one thing just as a user. I don't need a million photos like that. Okay, I'm going to leave this stuff. They're all cases where we're manipulating the image in direct code and not showing it here. Is album. Yeah, album sounds right. So I think I don't like leaving lint errors around, but I think this case we will. I think it'll be reasonably obvious that the accessibility ones don't matter. And then this one I consider a bug in SwiftLint, that it doesn't understand the multiple closure arguments can be outside the parentheses. Okay, so let's push this. I will certainly confuse myself slightly by that decision, but I'll take it. Okay, album. Okay, good. All right. So this is 15. Rabbit, 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 right? Well, we knocked through that pretty quick. Oh, make sure to check tests. I can't tell if they're being properly checked or not. It's funny, it didn't complain about where's that? Oh, I thought I had a class for this. Maybe it's not an issue. But I've probably done something in, I think we put the SwiftLint build phase stuff. Oh, is that only in here? Build phases. Oh, run script. Okay. I mean, this script should be run on the, I don't know how it does it. If it's running it only in that folder, let's add a script. Plus here, new script. Okay, we'll put the same script based on dependency analysis. For script to run on committal builds. Okay, that seems right. Okay, and we'll do a test run. Let's see if we get more than 4 errors. They may be okay. No? Okay. I wasn't. Yeah, well, they're running them twice. Yeah. I guess I could make an intentional error and see what happens. I'm surprised it's not complaining about that class name, though. Oh, now the editor will take care of that for me. Oh no, I was getting it up there. Okay, I'll take that back out. Well, I guess I can just revert this. And modify that again. Delete that stage from Collide tests. Okay. Good. Alrighty. It's just the to-do. Okay. Yeah, no, it looks like I don't have to add to the test, so that's good. That it already did, which makes sense. I mean, I think you're just running SwiftLint on the directory, and so it should see everything, but I got worried. Okay, well, that went quicker than I thought it might. So the issue here, let's see, I think I'll run it on my tablet. Actually, will it run? I'm not plugging it in. I'm just curious if it'll run just because it's on the network. Yes, it will. Okay, well, good to know. All right. So the 0360 thing is that the image on this is on the photo one only is controlled by the rotation, and the way it works is if you go 0 to 360, it's working its way. Well, it goes up and down with a sine wave, but works its way across the page or across the image, and when it gets to the far right side, it wraps around to 0 and goes back. So what happens is I perceive a slight jump at some point. I'm gonna have to do it this way. Okay. Here, green, 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 green. No, I'm not gonna see it. All right, that all looks fine. Well, maybe not. Well, that's just the most subtle change coming in. It is changing. It's very hard to see at a distance, I'm sure. Okay, well, let me try select a photo, because I was sure I'd seen this phenomenon. Oops, select a... Yeah, okay. Select a photo. Let me take... Okay, so this is a snapshot of some 2x2 grid or something. Okay. Oh, that angle. Maybe this is not a good choice. No, that seems to be opening. Well, maybe this is not a problem. Oh, there it was. Right. So we're over on some gray piece, and then we're over to green, and there's a jump there. Okay. Right. So let's see. Did I put together something for this? Yes. So yeah. So the way we are now, maybe this even animates. No. No. Okay. The way we are now on the left, the pie represents the piece we're selecting out. So we had an issue where we were getting white space in our images because we moved the triangle so that, or the little pie, so that some piece of it was outside the image boundaries and would show up as I think usually white, and then at some point we had it dominating, like half the screen would be white because it was just so far over. And so we did something to restrict the range so that the edge, stays inside, at least approximately. An approximation of the edge stays inside. I'm not sure we got to the very last pixel or not. But we would bounce up and down within here and end up inside the range. But that means that, like, if you stop, if you stopped when the triangle, you stop when the triangle is here, and then you say, okay, we're wrapping around, let's go back to here. And it clearly depends on the image, but this one you were looking at the brown wood on the edge, and then whoop, it goes completely away because of that. So my thought, yeah, so okay, so move twice as fast in X, and at 180 start to move in the opposite direction. Yeah. Um, that that may be a good way to do it. The way I was thinking was take the image, fold it in half, and then when you're here, you're fine. Well, no, this would not be good. It'd be okay in the sense that it would feel continuous, um, but it wouldn't be. you would never see this, right? This piece on one image. So yeah, so something's wrong. So yeah, maybe your way would be a better way to go. Um, let's look at, well, who does this? Probably Photo Kaleidoscope or something it calls. Okay, so Photo Kaleidoscope. I guess Collide View? Yeah, where's that sine wave? um, He's not capturing view. Oh, it kind of is, right? Okay, so let's go to angle. It's this stuff that does it. Oh, golly. not not the most pleasant thing, but the oscillation you suggest is definitely going to be better than what I talked about. Okay. So all right. So the x offset, I guess we need to say in a function what that is. Percentage of angle over 2 pi. Okay, so we take the angle, 0 to 2 pi takes us off the page. I want to make sure we get it flipped, when you're going back, like you say, move in the opposite direction. So, all right, so maybe I should just write this on, let's move this up and add a slide that's blank we can work with. Okay, so angle is the yaw, the rotation of the screen. So, well, let's just put some stuff out here. So angle ranges 0 to 2 pi. Okay. And then x, we've got to say, how does that reflect to x? And let's do this. Okay. So we want x, well, now it's 0 to pi. 0 to pi. This is that double speed thing you're saying. So for 0 to pi, we want x to be the percent. How's that right? We want it to be, well, okay, for angle 0 to pi, we want to take angle divided by pi would give us something, right? That would give us a percent across the screen to pi. Percent equals angle divided by pi. Now, for angle in pi to 2 pi, percent is, well, we gotta do something to flip it, right? So, is it pi minus angle? don't know, is that a plausible version of this? So if we're at pi, pi minus pi is 0. That sounds wrong. We'd like, okay, let's stay what they are. If you're at pi, we want it to go to 100%. If you're at 2 pi, we want it to go to 0%. Okay, so maybe this is like one of those places you can drive it out through TDD, but am I going the wrong way? Angle minus pi, angle is, yeah, I probably am. I mean, angle is greater than pi, so that's going to be better. Angle minus pi is 0 divided by pi is 0. So that seems 100% wrong. All right, so if it's 100% wrong, I think we're doing that. So if you get pi, you get 0. 1 minus 0 is 1, so you're over on the right 100% level. If you get 2 pi minus pi is pi over pi is 1, you get 0. Okay, that feels right. Okay. All right. Well, while I'm here, this code is its own thing. Okay, so let's make another function on angle. This is 2 positive radians of self. I guess we don't need that then. Okay. Whoops. I guess we'll make this just a variable. 2 positive radians for yourself is something like that. Okay. Working. The result is a double. Okay. Take yourself angle and then return working angle. Okay, so basically if it's bigger than 2 pi, we wrap it backwards. So if it's wrapped 6 pi, we're going to unwrap it. And then if it's less than 0, meaning we were wrapping backwards, we're going to add 2 pi and get it in the range. Okay. So this is self.2 positive radians now. And this should be gone. All right, I'm not changing any behavior yet, so let's make sure our tests are still good. And this is something we tested pretty well. Not perfectly, but reasonably. Compared to how ugly the process was to get there, especially. But yeah, I definitely like that move. Oh, and there we are with XC test. Boy, when it's failing every other time, this is there's some dependency issue, but XC test there should be no problem importing that. That's a standard, and it runs. So I think the compiler's a little off. Okay, but those tests run. Let's mess it up and make sure that well, I got a 2x offset. Okay. right. Okay. And that. All right. I do just want to force a failure on it. That makes me wonder if it's SwiftLint that's got the problem, not the compiler. If they don't realize it's there. Okay, bunch of failures. Good. All right. That should pass this time. And I want this. Okay. Extract method. All right. Now, I'm not sure the best way to test this in, but we tested X and Y separately. Okay. 0 maps to mid X. Now, 0 should map to 0, and then pi should map to 1, or maximum. Now, I don't know how we're accounting for the width of that piece of pi. Maybe I need that double image anyway. I don't know. It would simplify something. Pi maps to max x. Well, that seems to be what we want. Why is that 25? Width is 100. Well, max x, is that the most we're letting us go? Mid pi maps to half to max x. Yeah, I don't know where, unless the comments got out of whack, maybe, because we did change things around, but angle 0 should map to 0, okay? And (100) width, 0 is fine. Pi maps, well, where's 2 pi map? Above pi wraps around. That just doesn't even sound right. After I said I thought they were reasonably tested. Well, 0 maps to mid-x. That should be correct regardless. I think what we're saying is going to change is, well, we're going to test up to, I guess this is just before pi, and this is pi to 2 pi. So we're going to test if you're less than pi or over pi. So let's break this out. Okay, let's do it this way. If well, let's let angle equals self dot to positive. Okay, that's coming in. All right. If if angle is less than pi, is that okay? All right. If it's less than pi, do this, else do that. All right, I'll start off with them the same. So we're going to bend the shape of this method a little bit as we go here. Okay, so I'm putting in the if test for these two cases, but I'm doing the same thing regardless. That should not affect our test results. Okay. Right, so angle 0 to pi, it's angle divided by pi. Right. That seems the same. Angle divided by 2 pi. I guess it ran. All right, let's check that. Forgot I was testing on the tablet. All right, and let's switch to this. All right, so that seems fine. If I look at my test results, 0 maps to mid-x. Oh, we did screw around with that. Oh, no wonder. Okay, I'm saying I want 0 to map to 0 now. Zero maps to 0. Okay, that should still pass. Angle to x offset for this should be 0. Which one of these it's running even? Must be this one. Don't really care. All right, and then pi maps to max x. Oh, this is where I'm really... Okay. Pi maps to max x. Yeah, I guess I'm feeling like maybe what should be going on is kind of a combination that let's duplicate this. I think maybe this should be reversed. Okay, so no. Flip horizontally. That does not look horizontal. Vertically. Okay. Yeah. That's weird, but okay. Yeah, so I'm thinking maybe this should be like this. Whoops. Where's that pi? Okay, so if we put the images like this, then this can be 0 here, here at pi, and it'll already have wrapped around, but we'll have a line there because there's a vertical line where you slap the two pictures together. But that makes this circular, imagine this being circular and connected, on a round piece of paper curved back around. That's what we would get. What I think we're doing now is we only went to the halfway point because we knew that for any circle, this would be legit. Okay. So I think what will happen, let's see if this is right. Okay, angle to this x offset. Well, this one we're going to change, right? I'm going to change it. What am I going to do? I'm going to change it and then check the tests. It's a little unorthodox, but we want 1 minus angle minus pi over pi. So this is 1.0 minus angle minus pi over 2 pi. Angle minus pi over pi over pi. Oh, that should be pi too, right? 0 to pi. That's in effect my divide by 2. Okay. I feel like some algebra might make this work differently. Okay. Let's run this. Well, I think we're going to get something reasonable. It'll be a little different than what we've had. Well, maybe not. You won't be able to tell the difference at the start. And this doesn't rotate. So the thing being moved in the test. If the imagine width is 75. Oh, yeah. See, I think what's going on is the pi is only ever allowed to go from the left edge of it from here to halfway. And because if it were a full-size circle, right, it could only touch exactly on the far edge of here, and we know we don't have that because we're not doing a 100% circle. It's always it's usually at least 3. I guess it could be 2, but with the angle here, we know this range is safe. But I think if we did it like I'm showing here, we could go as far as this. Now as far as this, that's the repeat. So anything working its way towards that repeat is legit, and it's like it's a circular cone again. But we get to use the 100% range, 0 to pi here, pi to 2 pi going back, and then 0 to 2 pi here again. All right, now I'm going to leave it like it is. I'm going to leave it with those specs. We expect if you rotate, you're going to see some white space. All right, and tests are going to go wonky. All right, let's go back to the tablet. And we're going to run, and the pi can't be more than half the width. But we're being lazy making it just halfway because we could get further with, the smaller than half width pi. but we know it's safe up to the middle. So that's that. All right, camera doesn't care. I'm tapping out here and I get it. I'm not sure I like that, but okay. I don't. All right, this. Okay, rotating. I was sure we'd see white space. Okay, I don't know why. All right, let's work our way through the test. So I think we want to say 0 maps to 0. We want pi to map to max x, which is 100. Okay, so I'm just gonna run. I'm saying the first two tests should be right. We haven't tested them. The other tests, I don't know if they'll pass or fail, but I really don't know why. I thought this rule would have us seeing some white space, so we'll see what happens. Test and running. Okay, so 0 maps to 0 succeeded and this one failed. Interesting. Okay, so 0 to 0. Radians pi. Well, okay. That's under our if statement. So pi, it's less than pi. Otherwise, in our case, it's equal to pi. Pi minus pi is 0 divided by pi is 0. From 1 is 1. Oh, what's this half? Okay, I see. All right, this will be a simpler formula, I think, in the end. The half made sure we only ever got to the halfway point, so it came back at that. Now I think we'll see white space for half the screen. Okay. There it is. Yeah. And then back in. Okay. Because we're going out of range on the x-axis. Not far out of range, whatever that width of that piece of pie is, maybe it's a third. Okay. But my two tests should pass now. I mean, the alternative is we could do the same thing. Well, one alternative is we could do the same computation, only allow it to go halfway across. That's kind of what that did. Another alternative would be we could not be so mathematically lazy and figure out the horizontal width of that piece of pie, right? It should be either sine or cosine or some of these things, right? I mean, it's hard to say. Okay. Shouldn't be max 50. Yeah, I don't know what the right way to do this is. Okay. What is the angle of the piece of pie? We don't really know. Okay. Well, I don't know, maybe this half thing is just a good rule then for now. Let's do that again. Okay. And with that, then I expect this to be half, which is 50. I don't really. Okay, let's get this working and then we'll see. All right. So this should pass now. Let me add a to-do, taking a picture. should only let you tap on Kaleidoscope image, not white space around it. Okay, first two tests pass. That's good. Okay, if you got half pi, that should map to mid x. I think is a good way to say it. Mid x. All right, and then mid x is 25 in this case. Okay, negative pi wraps around. Yeah, okay, minus pi over 2. So minus pi over 2 gets you 90 degrees, minus pi gets you to basically plus 90 degrees, which we just said was 25. Okay, values below negative pi wrap around 3 times pi minus target radians. 3 pi minus pi over 2. Okay, so minus 1 pi gets you halfway, minus 2 pi gets you around, minus 3 pi gets you there, minus pi over 2 gets you to the same place. So 25 again. I don't know. I think you could say this directly. Well, okay. Yeah, I'll let it be. All right. Negative pi should map to min x. That's true, which should be 0. What do we get? Ooh, 25. All right. So negative pi maps you halfway around, which is, if you add 2 pi to it, is positive pi, which gets you to the same place. And in our case, plus pi should get you to this case, which is 1.0, and then halfway across. So I think that should be 50. Oh, good. Okay. Yeah, I think we're doing something. Negative half pi maps to, well, that's negative 90. So that should be 25. Yep. Oh, that's true. There probably is. We could probably get that shape and pass it in. All right, value just above pi wraps around. Well, this is interesting to us. So pi plus pi over 2, okay, is bigger than pi. So pi, 3 halves pi, 3 pi over 2. Angle is greater than pi because it's pi plus pi over 2. So angle minus pi is pi over 2 divided by pi is 1/2. I think that should be 50. 25. All right, I think this last case is the only one we're going to be failing right now. Okay, so if it's pi, that gets us all the way across. And then pi over 2 gets us halfway back. I feel like that should be, should be a 25. Is that what it said? Yeah, halfway back is 25. Okay, well, it'll fail. Oh, did I not run the program I ran? Need to run the tests. Okay, I think we're okay. I think we need better tests. I think we need a couple of tests to make sure that the back and forth behavior is working correctly. Yeah, you're right. All right, test is running. Now, mostly our y we're making independent of our x, so this should be all right. That's good, and then just run it. Why are you saying that now? Half pi maps to mid x. Half pi. Well, why did you say they all passed, and why is one showing up as not passing? Half pi maps to half. Oh, I deleted that test. Okay. All right. I can't tell. Oh, I'm running here. Okay. So that's looking pretty good. We still should have the white space problem. Oh no, we shouldn't. Because we only go to halfway across. I don't know if that's where the crossover line is. Seems very subtle there. All right. That's definitely better. Okay, let's figure out this test situation. All right, 0 maps to 0, pi maps to max x, half pi maps to mid x. In a way, this reflects more the order we wrote them, and I think maybe this would be better. All right, so half pi, let's test a quarter pi. 1/4, 3/4. I guess we'll do quarter pi first. I don't know, maybe I could say this quarter pi maps to quarter x. All right, so this is pi over 4, should be 12.5. Okay, half pi maps to mid x, and then 3/4 pi. Maps to 3/4 x. All right. Pi over 2, this is 3 pi over 4. Should map to 37.5. Okay. Pi maps to max x. So the test order is 0, quarter pi, half pi, 3/4 pi, full pi. All right. And then let's run those tests. Okay. I'm demanding it. Okay, who's running? Okay, they both stopped. I should probably clear test results and make sure that things. Yeah, I think it would be easy to understand too, but I think we'll have to make sure the image stuff works. I think it's the next phase. We'll put that in place today. But now this stuff, these are really they're really testing that wrapping thing. Let's make a class for them. Final class, to positive radians test is XC test case. Okay. And I don't think we need to test the negative values. Well, we'll need to test the ones just above, just above pi and stuff like that. We're going to go around the whole circle. All right, but these radian tests, all right, where's that clear? Okay, values below negative pi wrap around. So I want to say angle dot radians dot to positive radians. Okay, so if you got minus pi over 2, minus pi gets you halfway around the circle, minus pi over 2 gets you up to 90 degrees. So that should be the same as positive pi. Pi over 2, rather. Okay, so minus 3/4 pi wraps around to, let's call this radians. Wraps around to pi over 2. Value is well below negative pi. Okay. 3 pi, I don't know. I'm going back and forth on this, but let's put it like this. Dot to positive radians. Okay. 3 pi minus pi over 2 should be minus 2 pi wraps around completely. It should be the same. Okay. Negative pi should map to, well, negative pi, let's say wraps to pi, because we're adding 2 pi. Okay, and then negative pi wraps to pi, yes. Okay, negative half pi maps to, well, negative half pi if you map that around, that should add 2 pi. That should be 3 pi over 2. Hopefully my doubles aren't too screwed up. Okay, so this range, 3/4, this is all up to pi. And then I think we're just going to keep going around. Func test pi. That's right. Yeah. So I should never normally I'll never be dealing with the negative stuff in angle because we force it to the positive radians right away. Also, I wonder if that can be a let. Oh, pi pi plus pi over 2 maps to, all right, we'll fill that in a moment. Okay, so I guess that's pi is 3 pi over 2 over 2. Okay, so 2 pi reps there, going back a half a pi, right? We know the answer should be the same as half pi, so 25. Come on, mid x. All right, so 3 pi over 2 should map to 25. Okay. And then three pi over 2. That's the halfway. Let's get pi plus half, 3/4 pi, 5 pi over 4. 4 maps to, okay, so 5 pi over 4 is pi and then comes back halfway. So I think that should be 37.5. All right, and let's move this up because it's slightly between those. Okay, and then 2 pi, does that ever happen? I think if it's 2 pi, it's going to go to 0. So we don't really hit 2 pi. But we can put the last, well, if that's 5 pi over 2, I guess 7 pi over 4, 7/4 pi. And that should map to 1/4 x. 7. Oh, did I not do this one right? Yeah. All right, 7 pi over 4 should map to 1/4 x. That's 12.5. Okay, this is wraparound tests. I think we covered all these. Well, that one would be good. These two would be good up there. All right, so I'm going to add these into our angle test. Well, that's the neg, so let's do the positives before the negatives. Value just above pi wraps around to positive radians. Well, that should be 2 pi. Should be pi over 2. This is radians. value well above pi. Okay, 6 pi to positive radians should be 0. And yeah, below negative pi wrap around. Okay, I think we're good. Seven over pi needs a better calculation. Did I not calculate any sevens involved? Yeah, thank you. So 7 times pi over 4, okay. 3 pi over 2, 5 pi over 4, pi, 3/4 pi, half pi, 1/4 pi. Okay. All right. So we made x coordinate wrap back and forth cyclically. Okay, and that is cool. Okay, now I think it's clear we could have calculated the whole thing. I don't know. Let's see. Okay, so I don't think that jump is there. We didn't see it. I think I was assuming it existed. But with the way we're doing it now, you're always smoothly moving across back and forth. There's no jump. So I guess we did eliminate that. All right. But what we did was we made x oscillate back and forth between 0 and half the width. So pi can't actually reach the far right. Okay, yeah, parameterize test for these. That is probably fair. I'm lazy. I know. It's all I have to do is add the package in and do the test. So let's do that because we're going to change it again. All right. So clearly that's something we need to do. All right. So add package dependencies. It's probably sitting right here, isn't it? P-test, EG test. Yeah. Okay. And angle to XY tests. For EG test. No such module. No, he's catching up. Okay. Well, all right. So I always have to go back to the examples. Okay. So we need our check. I don't think we need this array anymore, do we? And then our code. Okay. Angle tests. Okay, so we'll do function check to positive radians. I guess that's test to positive radians. Okay, and then short-term memory here. Check. And I think we have one that takes a list of them. Okay. A list of tests, and then does this with example in. Okay. And our first, our code is, I don't think I have an EG assert with fuzz. That'll give us something to do. EG assert equal, assert throws. Okay, we don't have one that handles fuzz. All right, we can do this as is for now. All right, so radians in, well, the input is eg.input. All right. Example dot input. Actually, you know, I just do $0 when it's simple. Okay. And then the output is, that's still radians, but this is $0 dot expect accuracy fuzz. Okay. What we don't have is EG assert equal that looks at this for us and takes the accuracy. All right, now this is EG. The input for this case is, well, 2 times pi plus pi over 2. Okay, yeah, let's just take it as is. We expect pi over 2. Oh, really? Do it that way. Okay. I think because it's generic types, it's maybe losing a little type accuracy. All right, whoops. And then we have a string to explain the situation. All right, so this is just above 2 pi wraps. All right. And this test should pass. All right, what's the problem? All right, let's do some cleaning. Day. Isn't there somewhere you can see these errors? if I didn't. Oh, I got EG test there. Yeah, let me kill Xcode. All right, it's a good time for a break anyway. So I'll restart that thing. We'll come back in 4 minutes or so, and hopefully that will wake it up and it'll do better. All right, welcome back. Yeah, rebooting Xcode did not fix this. I thought. Review and log. Double. I don't know. Something's off. Do I need these guys to know it? Target dependencies. Collide. Maybe this needs it too. And this doesn't? Oh, there we go. Okay. Could not find XC test Swift support. Core audio tests. Could not find XC test. That's just weird. Okay, lots of people seeing it. Enable testing search paths. Test classes should only be in the test target. Xcode 12. That seems off. Test assertion is limitable. Build phases link binder with libraries. Well, let's see this one first. No. Okay, that didn't help. Target name, build phases, linked binary with libraries. Build phases, binary with libraries. EG test, what about you? Huh. He shouldn't need them. All right, let's see if that helps anything. My downs, my pi dot bounds dot size. Okay. There we go. All right. So I have it in collide test. I'm going to take it out of there in collide in a moment. Well, assuming the test passes. But I actually think the size, the width of the pi is not enough. Let's see. Okay, so this was good. I'm going to take this one out. I'll do a clean and run again. All right, while that's running. So what I think is the case is if we did that, we would say 100% is the total width of the image minus the total width of the pi, and so we would allow it to be this is 100% across. I mean, it's pi because of our oscillation, but 0 to pi, and yet we would never see this. We would never see some stuff. We'd never see this, anything past here and beneath the piece of pie wouldn't show up ever. So we'll never see the bottom of that. So that's why I'm thinking this wrapping thing might be a good thing. And then we don't have to worry about the pie because we're just not going to go across the wrapped distance. But that's okay. All right. Let's check this in. So add parameterized test. It would be good. I mean, it would be better than what we have for sure to do that with the pi, but I think we can do better. Yeah, and I can say why too. So like now we're at 50%. I think we still do have some jump. No, we don't because the oscillation. Well, maybe it's okay. Yeah, that would still be an improvement. We'll do that. Let's get these parameterized tests in first, though. All right, so this test 2 pi plus pi is covered. Now let's do 6 pi. Six times pi, expect 0, and this one is, well, above pi wraps. I think around is a little redundant. Okay, and then may as well add the other. Below negative pi. Pi over 2. I think this is really just negative value wraps. This is well above 2 pi. Minus pi over 2. That's this one. We want this one to pi over 2. Come on, next code. There we go. Minus 3 times pi, minus pi over 2, expect pi over 2. More negative value wraps. Minus 3 pi over 2 minus pi over 2. That was the last one. Oh no, this one. Negative pi minus pi goes to pi. minus pi, expect pi. It's 2 pi to negative. And one more. Okay. Negative half a pi goes to 3 pi over 2. I'll just say negative to positive. Okay. These should all pass. Yeah, it's interesting. I think what's happening is the first time, well, doing this forced the type to double. I'm not sure why it was ambiguous before, but I think once it becomes double, the others are fine. So I can inline that. Are we still building? Okay. Yeah, it is a little goofy. It's just weird. It takes extra time sometimes. I can't tell if it's really doing anything or not. And then at insult to injury, it'll come back and tell us, it ran in 0.03 seconds. I don't know if is this maybe making it more complicated for it with the dot pies and the pies. All right, and while that's doing, I'm going to look back at the SwiftLint documentation and mark those places I don't want to worry about these things. Da, da, da. Yeah, I never got over that, maybe. Still, so weird. Rules. Disable rules and code. That's what we want. Yep. So this one, yes it is. Okay, let's make these all the same. Oh, I was trying to do that the right way for a one line. Disable colon this. Okay, well that's good. Let's fix this last one. Oops. Okay, and then these tests can go. Okay. It's spent too long looking at those errors, though, I will say. All right, let's get this test going. Well, let's borrow some of this. Yeah, let's take this one as our model. Okay, the first case is, well, angle.radians, we can say 0 here. Expect 0. Oh. Um, no. Oh, I don't have line and file? Seems funny. Yeah, I should say file and line. And this should do the same thing up here. Okay, let's run these tests. Unexpected comma separator. Really? Okay, so pi over 4 maps to maps to 12.5. Quarter x. Okay. Half pi to mid x. Three-quarter pi. Pi to max x. Okay, let's see how these do. I don't know what I'm getting that for. Like, Got it set to run iPad. Xcode will continue, yes. Okay. Okay, so let's take out 0 to pi once. Five pi over 4 goes to 3 pi over x. Well, actually, this one's probably 5 pi over 4 goes to 3/4 x. Five pi over 4 goes to 3/4 x. 3 pi over 2 goes to half x. Seven pi over 4 maps to quarter x. Am I making this tight stuff bad? Oh, it's going okay. And I would say for this stuff, there really is no reason to run it on the tablet. Does not want to rename that. Nothing calls it, so we'll just clean this. I think this is really 2x offset. And this is really 2y offset tests. Whoops. Where it's running. Well, I'm hoping to speed. Yeah, well, I think let's see, because I made this a 0. I I, I mean, I don't know. It's like generics, they have to like map types and decide which one maps what. But this constant is a double, so this is assumed to be a double, which it implies this has to be a double. Now I probably could put the dot O's in there. Well, maybe it's saying testing, right? So I don't know. It it seemed like it restarted the simulator or something in there. So let's try again. And it did a full build, so it was like 96. Well, it keeps going up and down. Build succeeded. Okay, waiting for it to start. So I don't know. Is that seconds or is that how many clones I have kicking around? Oh, how many preparing editor functionality. Now, is it running or not? I don't know what preparing editor functionality is. Okay. I guess that's not really what we're doing. We're parameterize tests. And then we're going to restrict show. Did I run it instead of testing it? Show more of the picture by taking the pie width into account. I don't know. It says it's supposedly done building and should be running tests now, but maybe it's just that first connection. Well, I'm going to exercise my impatience and start building this one. Zero. Let's take this code. Yeah, I'm not sure what's up. I I don't see how I'd get an infinite loop doing this stuff. It's sort of a plain old function, and I don't know. Maybe I'll reboot my whole system at some point after the session. Okay, so y angle radians 0 expects minus 25. Now this one's kind of a separate test. I'll comment them as we do them. Okay, good. Pi maps to negative middle of radius. I'm not sure that speaks to me as much. This one's confusing, but negative pi maps to negative 25. Negative pi maps to mid x. Is minus 25. Half pi maps to 50. Half height minus radius. Negative half pi to minus 100. Well, that can be right. Negative half pi. V3 should say pi radians. Yes, thank you. Minus pi over 2 goes to minus 100, which is minus half the height. And then repeats, I think, is again a different test. So. So I'll need these three. Where's the simulator running? I don't know where it's actually running. I don't think it's this one. Well, I'm going to put these, make these explicit doubles here. I don't know, I should do that here too. Because I do think there's some complexity that when we do it with this, we're saying, okay, the first field is going to be a double, and it has to say, can you match it to a double? Well, it's a division. Is it a double? Well, I don't know. It's got a potential double over here and an integer. Can we make this dot pi an actual double? Yeah, you could use double dot pi. It's a bit of work. I hate having to do it. It feels like it should just be a compile time simple thing, but I'm afraid that the price of generics is maybe that it's just not that easy. Okay, so I put decimals in all those. I don't know if that's really, I'm giving up if that's not clear. I'm trying to give up. Product, clean build folder. Wow. No, I don't have it deployed on the App Store. That might be a reasonable project. I mean, I think it's in reasonable shape for that. We don't do dark and light mode. There's other stuff that you would kind of do. Okay. Okay, I did a clean build. This indexing just seems to be going on forever. What editor functionality? Sorry, let me look at that. Now, back to this. Unexpected separator. Okay, that one. It's like it didn't compile. Such module EG test. Okay. EG test is in Collide tests, which is the only one that uses it. Okay. Package dependencies, EG test, yes. Okay. So let's take this down again. Let's clear everything. Okay, and run tests. Other apps in the App Store. I had one and the project went away, so that one's gone. I don't think I have anything else out there. It's definitely my intent. The kilt calculator one we've been doing. Well, we're actually in the process of moving, so my wife was going to check with people and see if they would try it and stuff, and that kind of fell off the end of things. But that one we will put on the App Store, and then I think this one could go there. It's I'll get dinged for a couple of things the way it is now, but the other one I'm thinking of is like we put the sound in yesterday in the motion. You're really supposed to respect some flags about whether or not you do those things, because some people are sensitive to motion, find it confusing. You want to be able to turn it off, or they don't want sound. So I know we'd have to do those things. I think we're supposed to do dark mode, light mode, and that one's a little funny for accessibility, but yeah, I'm not sure what they would expect there. So yeah. Okay, launching, that's a good sign. All right, where's our tests? Okay, and now I can get rid of these. Oh, there's something that finally woke up. Okay, these tests are the parameterized ones. Okay, I'm just going to pull it to a side window. Yeah. And I haven't noticed other ones out there, so yeah, I should get on this. All right, so let's run this one last time. So I think the conclusion for today is, I think the next step, we did parameterized tests. I really think we should do this thing taking the pie width. So I think what would happen is we would say, well, maybe this is the right place. We would say 0 to, we would pass in the rectangle being bounded by this piece of the left side of the piece of pie. And so we could say 0 to 100 being the whole width that you're given. And on the outside, it would actually be wrapping onto the image that's bigger, but it would deal with the coordinates already. Yeah, settings is probably right. We've got it set to a fixed number of yeah, we hard coded 10 mirrors and 3 repeats or something. Yeah, more settings. Let's put it on my to-do. Put app on the App Store. Okay. All right. But I think if we did that, so we would, instead of going to halfway, we would say 0 to pi is 0 to pi is this restricted width. And in the reality, it would show it to the width of the full image. but we would call 100% the far right side. And I think that's a doable thing for tomorrow. All right. So, yeah. So make it go 0 to 100% in the x-axis based on image minus image width minus pi width. Okay, so something like that. I think that would be a good one. Yeah, name of the album, number of pies. Well, we have a constant for that number of oscillations. Oh man, I keep freezing up. Yet another clone opens instead of just using the one they already used. Yeah, so somewhere here, okay, we have mirrors on this one, and we don't have photo kaleidoscope open. This one has the sine repeats, so this y-axis stuff we're doing. Yeah, I think that tap. I want the tap to be only on the kaleidoscope. Did I catch that one? Yeah. And I don't know. We may do this one tomorrow. I don't think we'll do the lens stuff, but maybe just to do the repeated images, just to see if that's any good. Yeah, background color you could do. I don't know if there's any camera parameters. I mean, you could theoretically put more filters and stuff in, but I don't think you need that to be fun enough. Yeah, well, we'll have to see. But yeah, I mean, even if it's just 3 or 4 settings, that would be enough to do it. I could see something other than plain white. That's a bit vibrant. Maybe a light beige by default and in light mode, and a dark beige in dark mode or something like that. All right. Okay. Well, so today we fixed that SwiftLint stuff. We improved this 0360 thing with the oscillation thing, which I really like. Yeah, I got to leave something for V2. And we updated our test to be parameterized. So this the oscillation now works like this: from 0 to halfway through the image, and then back to 0, and then back to halfway. That's the x-axis. The y-axis is bouncing up and down this whole time. Okay, but it only goes that far on the full image. And tomorrow we'll experiment with the restricted image and see how that goes. I think if we put the pi on the restricted, for the computation will now say 0 to 100%, which seems so clear. And maybe the oscillation, the y-axis thing should be made that clear too. So, but I think we got a couple other things we want to get done tomorrow. I'd like to call the project a wrap for tomorrow. But I'll take it as a thing for me to do, is to explore putting it on the App Store. It'd be good. All right. Well, thanks for joining today. Thanks for the suggestions along the way, and we'll pick up tomorrow, 2 to 4:30 Eastern, 6 to 8:30 p.m. UTC, and hopefully see you then. Bye bye.